Chapter number 3. This is motion in a straight line. We are discussing motion in a straight line. Very common phenomena. Something is static or something is dynamic. That means moving or non-moving. So motion is common to everything in the universe. While you are walking, running, cycling, your blood circulation in the body, the flow of water, the flying birds, these are the examples which you will encounter or see in your daily life. Some motions may be invisible, that is the random motion of gas molecules we won't be able to see. The electrons flowing in the conducting wire, again, they are invisible. So stationary looking objects like the roads, trees, buildings, these are in motion with Earth's rotation. And also the Earth would revolve around the Sun. So if this is says Sun, then Earth would revolve around it, and simultaneously it will rotate on its axis also. So this revolves around the Sun, and the Sun itself is moving or in motion in Milky Way. And Milky Way is also in motion with respect to other galaxies because we are in Milky Way. So we can say that everything in the universe is moving. So when any object will change its position with respect to another object, that is, if this is an object, this is an object, and this is moving with respect to this object, we say that this object is in motion. And motion can be of various type. It can be linear, it can be rotational, it can be vibrational, like the oscillation. You have seen the pendulum. So we will confine and we will discuss about the straight line here, which we also know as a rectilinear motion. So we'll try to understand the displacement, the velocity, and the acceleration. Kinematics and dynamics. Now the branch of physics which is dealing with this motion without even considering about the causes. So dealing with motion but not able to just not considering the causes, these are known as kinematics. But that branch of science which describes the motion, something in motion or moving, along with it, the causes are also being investigated, the properties, the causes of a moving body, and this is known as dynamics. The kinematics and dynamics, they both are combined, and collectively they are known as mechanics. So in this chapter we'll discuss only about kinematics. What is the concept of a particle? Particle, anything, we take a car as an object or a bicycle as an object. So we will treat the object in motion as a particle. A particle is a point-like object which is having certain mass. It is endowed with some mass, and they must have some dimension. But in certain scenario or situation, the circumstances, an object can be treated as a particle. What are the circumstances? First is, all the particles of a solid body, they perform linear motion. They would cover the same distance at same time. So motion of these bodies, this can be described in terms of motion of any of its constituent particles. So if this is an object, these are the particles. Any particle inside this, and this whole as a particle will cover the same distance at the same time. If the distance between two objects is very, very large, as compared to their dimensions, then these objects will be known, and in the mostly in the computation level, we will compare, or we will say them that they are very small, or they are just particles, point particles. For instance, the calculation of gravitational force between, say, Sun and Earth, both of them can be considered as particles because the distance between them is very large as compared to the dimensions of these objects. Frame of reference. Frame of reference is very important, and you are free to choose any frame of reference. The question is, before we start about discussing frame of reference, the question is, How do you know that object is at rest or in motion? Here is an example. We have a train and we have a bag here, say, right? Here's a bag. Now, you are here somewhere. The train is moving with some speed, and there is another person here. Say some trees are here. Now, for this guy, and the train is moving. For this guy, this bag is stationary. For this person, because this train is moving, this bag is in motion. For this person, because he is standing along the tree, for this person, this tree is static. It's not in motion. Okay? It's not moving. But for this man, or for this man, this tree is moving. So it all depends on the scenario and the frame of reference. A person in the train would find the bag stationary, as I said. But the person who is standing by the roadside would find this bag in motion. So it is observed, this bag is observed from the train. It is in motion. He is observing it. He is observing it. But if you observe this tree, the building which is outside, they are stationary. They are stationary. But as we observe from here, but as the train is moving, the person here would see them as in motion. So motion is a combined property of the object which is under study, that means this object, along with the observer. Where is the observer? Who is the observer? In other terms, we can say that motion is a relative concept. You understood this? This is a relative concept. So let us say that a place and a situation from where an observer takes or looks at the object or take the observation, this is known as frame of reference. In this example we discuss the bag, the frame of reference of the passenger is the train moving with a constant speed, while the person who is standing outside on the road, the frame of reference is not train but earth. So the frame of reference can be of two types. One is inertial frame of reference and the other is non-inertial reference frame. We will discuss about that in the later discussions. Position, path length and displacement. Let me ask you a question. You started from here, you went to uncle, you went to auntie, you went to your grandfather, and then you came back. How much distance have you covered? What is the position you have at different time? And what is the displacement? The answer would be that the distance is from here to here to here to here. Let me say 1 kilometer, 2 kilometer, 2 kilometer and 5 kilometer. So the distance you covered is 1 plus 2 plus 2 plus 5. That is, it is 10 kilometer. But what is the displacement? Because at initial from here you started, then again you came back here. So the displacement is according to your position. You haven't displaced. You moved a lot, but you came back again to the same position. So your displacement is 0. Now this seems to be somewhat new for you, but we will discuss and you know that what is the distance and what is the displacement. So to locate the position of a particle, we always need a frame of reference. We cannot just say that this is a position. From where it is related, from where you are watching. So there is no rule or restriction on the choice of frame of reference. You can take any frame of reference. We can select a reference frame according to your convenience. It's up to you. Normally we choose this. This is X, this is Y, and this is Z axis, Z axis. Now any point, say here, 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 you can always find the X distance, Y distance and Z distance, and you can say, okay, this is the X, Y, Z position, X, Y, Z position of that object. Now you have a frame of reference. This is a reference point. You can start with this. This is a 0 reference point. And along the axis Y, or you can say along XY planes, YZ plane and XZ plane, you can easily point a value, the coordinate XYZ of a particle, which describe the position of any object with respect to its frame of reference. This is known as coordinate system. So according to this reference, or you can say coordinate system, the position can be easily obtained. Now you started from here, say in time 10 minutes you reached here. In 20 minutes means in 20 minutes you reached here, so you took 30 minutes to reach here. So this is T1. At time T1, your position is this. At time T2, your position is this. T3, your position is this. Likewise, we will understand. And at this was T0, and again T5 is here only because you came here back. T4. So this is all the way in which we are going to deal with different aspects of your path length and displacement. So here is an idea. You were here, x1, y1, z1 at this point. Now at T1, you reached here, means you followed some distance, you followed some path, and at point B, at x2, y2, z2, that is the x distance, y distance, z distance from the coordinate system or origin, you are here. So this is from origin and this is again from origin, right? So this is a position of a particle in frame of reference, which is our x, y, z coordinate. So in this scenario, the position of coordinate of a particle in motion at time T1 is x1, y1, z1, and at time T2 it is x2, y2, z2. So this shows the position of particle with respect to given frame of reference, which is your x, y, z coordinate system. If all the three coordinates of a particle will remain unchanged with the time, then we say that the particle is at rest. That means x is 2, y is 0, and z is 2. This is x, y, z position. Now with this is at T1, you say at T2, you are at 2, 0, 2. Again, now neither of x, y or z has changed. That means you are at rest. If one or more coordinate of a particle changes with time, then we say that the particle is actually moving. If any one, say this one, this one, this one, this one, or this one, any of one coordinate changes with time, then we can say that it is in linear motion. When an object is in linear motion, when any of these x, y, z, any one of these, only one of these position changes, other remains the same. If we have an object which is falling freely from top of a tower, the motion of a car along a straight road, these are example of linear motion. Now, when 2 or 3 coordinates, means not one but xx, yy, or say x, y, z, so 2 or 3 coordinate change with time, the motion of particle is called 2 dimension, because 1 dimension has changed, linear motion. 2 dimension change, we get 2D motion. When 3 dimensions have changed, we can say that these are 3-dimensional motion. The earth which revolves around the sun, the striker moving over the carom board, these are 2D motions. But a butterfly, the butterfly is free to move in any direction, any way. So the butterfly may be changing all the x, y, z position. Then we say that the butterfly is moving or flying in 3-dimensional motion. Let us describe the motion along a straight line. We will choose an axis and say this is an x-axis. Why we are choosing only one axis? Because in a straight line motion, only one of the coordinate change. Say x is the direction in which the particle or the object is changing its position or moving. So it coincides with the path of the particle, this x-axis we have taken. Now we can decide the position of a particle with reference to some origin. Okay, this is the origin, we have taken this. Now the position to the right, we will take it as positive, and if the object is moving this side, we will say it is in the negative side. Okay, here positive, here negative. Now in this scenario, what is happening? The object is not starting from the origin. The object is starting from the position A, that is already 20 km ahead of O. Now the object has taken or is in motion and it moves to B. So how much distance it has traveled? 20, 80, that is 80 minus 20, which is 60 km it has taken. At 80 it turns back, it moves back till it stops to point C. Now again in the opposite direction, because this is 60 it has taken, in the opposite direction from here, if we say it is 60, now again it is coming back, so it has to be in the negative direction. So 80, 40, how much distance it has traveled from 80 to 40? It is 40 again, but it is in negative direction, right? So this is the scenario we will be going to take in various discussion from now. So what is the path length? The path length is the total distance traveled by a particle in some time interval. This is called the path length or total distance. Means how much you have traveled is computed totally, and that is the path length. But the displacement is something different. That is the change in position of a particle in some time interval. This is the displacement. So there is a difference. If x1 and x2 are the initial and final position, and this x1 is at your position at t1, x2 is your position at t2, then the displacement in time interval, that is t2 minus t1, delta x, the displacement will be simply final position minus initial position. We are not worried about the in between positions, only final and initial. You can say that I move from here to this point, right? So the distance is totally this plus this plus this, but the displacement is this one. This is the change in the position. If you try to find out displacement in this position, it will be this distance. Displacement from this point to this point, this will be this one, and this one I already told you. So displacement is different from the distance. The SI unit of both the path displacement and path length and displacement, they are known to be carried out in meter. So let us again talk about the difference between distance and displacement. Now the time interval was t2 to t1 in the discussion we had. The path length was what? Let us see. From 20, the object moved till 80. So what is the distance? That is 60. Now again it moved back from 80 to 40. What is the distance covered? That is 40. So 40 plus 60, this is the total distance covered. So 100 is the correct path length. But what is the displacement? I'll take you again to the diagram, because displacement has to be understood. Displacement is, it started from A and then came back to C. So ultimately from A it started, and after moving somewhere it came back to C. So this is the only path displacement. So 40 minus 20, that is, it is 20 kilometer displacement. So I hope you have got the idea of distance and displacement. So path length and displacement in this case are both positive. Displacement is directed in the positive direction if the car starts from B to C, as you saw in the figure. So path length was 80 minus 40 and displacement was 40 minus 80. In this case the displacement was 40 minus 80, so it is minus 40 kilometer. The displacement can be negative. Distance will not be in negative, but displacement can be negative. So displacement of car is in x direction, and in the example we have seen car starts from A, goes to B, return to A. The total path length was actually 120, but the displacement is just 0, because if you say it starts from here and comes back to this point, then the total distance will be 120, because from this is 60 and again this is 60, so 60 plus 60 is 120. But this is A, and say that the final position is say C, and it came back, A and C are in the same position, that is, the displacement is 0. So path length is always positive, while displacement can be either positive or negative or 0. Okay. So displacement is just the resultant effect of motion of car from where it started and where it ended. This is displacement. And displacement both have magnitude, as you see this is magnitude, and also the direction. If you landed here, this is the magnitude, but this is the direction. These are the directions, and these are represented by vectors. We'll learn about these vectors shortly. So in one dimension motion there are only two directions. It can be either this way, or either this way, that way. That is backward, forward, upwards, downwards, in which the particle can move. And if we take this as plus, then we have to take this as minus. If we take this as plus, this is minus, and vice versa. So a particle moves along a circle of radius r. It starts from A. In anti-clockwise, that is, in the opposite way the clock moves. Calculate the distance traveled by the particle and the magnitude of displacement of each of the following case. So from A to B. Now A to B. Before we discuss about this question, first is a circle, and we know that the circumference of a circle is 2 pi r. This is 2 pi r. Now this is the 1/4 of 2 pi r. So this will be 1/4. The distance will be this one. How much is this from A to C? This is 2 pi r by 2. So distance will be this. How much about this? This is 3/4 of a 2 pi r, right? Yes, this is 1/4. 1/4 of 2 pi r, so this is 3/4. And how about this? If it starts from A and come back to A, what is the distance? This is complete 2 pi r. So these are the distances. Let us know the displacement from A to B. Now the displacement is this one, not this one, but this one. So this is r square. This is r square. We'll use the Pythagoras theorem, r square plus r square under root. This will give you under root 2r. And when it reaches AC, what is the displacement? R plus r, so 2r. Again, when it reaches D, what is the displacement? Again, because this is r, we'll again use the same formula, and this will be under root 2r. When it comes back, it will be 0. Displacement will be 0, and distance will be total covering. So this is what is being shown here. Distance traveled by a particle from A to B is 2 pi r by 4 in the first case, A to B. And the displacement is under root r square plus r square, that is under root 2r. And from A to C, that is this point to this point, it will be 2 pi r by 2, because whole circumference is 2 pi r. So it will be 2 pi r by 2, that is pi r. Displacement is what? R plus r. This is from here to here, it is r. From here to here, it is r. So displacement is 2r. From A to D, that is this point to this point, this has to be taken totally. So this is 3/4 of 2 pi r. 2 pi r is the total circumference. So we have to take only 3/4. So this will be the path length, and distance again, displacement again will be under root r square plus under root r square, under root 2r. But at this final position, if we come back here, the displacement will be 0 and distance will be whole 2 pi r, which is being shown here. The path length will be 2 pi r, displacement will be 0, because the particle has come back to its original position, and because it has traveled totally, the path length or the distance will be 2 pi r. Average speed and average velocity. Why it is average speed and why it is average velocity, we'll know by now, after discussing this scenario first. Means when an object is motion from here, so it is moving. And how to know, and this is very important, that we need to know how fast is the position of changing of an object is changing from time, with respect to time. T1, the object is here, T2 it is here, T3 it is here. So the ratio of path length, that is the total distance from this, just add all these, to the time interval during which the motion takes place from T1 to T3 say. We know it as by average speed. We denote it by V, or a bar on a V. So the time interval, average speed is totally speed equal to distance by time. This you need to just remember. Speed is distance by time. Path length is total distance from this to this, and time interval is t from say T3 minus T1. So if an object travels say a distance delta x in time interval delta t, the average speed in this time will simply distance by time. V will be x by t. So now the question is again, how fast the position is changing with time, right? We have to define this with the average velocity. Average velocity is the ratio of displacement. Please understand, it is displacement by time, in which this time the displacement has occurred. So average velocity will be displacement by time x by t. Average speed and average velocity, they have SI unit, meter per second, because meter per second is very small as compared to the large distances. We generally compute it in terms of kilometer per hour. And the direction is very important with respect to, or when we are talking about average velocity, because average speed, there is no concept of direction. So the direction has to be taken in certain sign. This is plus direction, this is negative direction. So we do not use the vector notation for velocity. We'll try to learn this with respect to vectors in coming discussions. Say if t equal to 0, the car start at A, it goes to B and return to C in 2 hours. So what is the total distance we have discussed? Say this is say 60, this is 40. So it is 100, the path length is 100. And the time as said 2 hours. So 100 by 2, that is this 100 kilometer, okay, 60 plus 40. and this is B, this is C. So it traveled to 60, then 40 came back. 100 is the total distance and divided by 2, which is hours, so 50 km per hour. But what will be the velocity? Velocity will not take the distance, will take the displacement. So from this point, say to this point to this point, say this was say 40 and this is 20, so 40 minus 20, it is 20, and 20 by 10 is 10 km per hour. And we need to understand about the sign of the velocity, because sign is very important. The sign says that the average velocity of the car is actually in the positive x direction. So now the car moves from ABCO and comes to O in 3 hours. Let us just assume that the distance is 140. That's, we say 140 by 3, that is 46.6. Now an object goes from this point and again comes to this point. It means it reaches ahead of it. So say this is 0, this is 20. So now this is minus 20. So average velocity will be 0 minus 20 by 3, say in 3 hours. So it will be negative. So average velocity of a car is in negative x direction. So the average velocity can be positive, negative or 0. Average velocity can be positive, negative, it is 0. It can be 0. So it depends totally on the sign of the displacement, and in general the average speed of the object can be equal, can be greater, or equal and greater than magnitude of average velocity. It will not be less. So what is the average? Average is why we are using average again and again. See, while you are moving, say from Ahmedabad to Vadodara. Now there is a very good road, there is an expressway, you went from here to here in say 80 km per hour. But at this point, from here point, there is a congestion. So you had your speed at 20. From this point to this point, oh, here also you stopped. Okay, you stopped for say 10 minutes to have lunch or your drinks. Then you reached here with some other speed. Now the total distance you traveled, you had different speeds. So we cannot have all these speeds. We need to take the average of the speed. So the average from A to say B or Ahmedabad to Vadodara, from A point to B point, is 50 km per hour. But though it is not representing the actual speed you maintained during the travel, because at some time you were 20 km per hour, at some time you were 80 km per hour. So when we combine then average them, then we say that it is some 50 km per hour. I hope you got the idea. So a vehicle's start or a vehicle travels different distances with different speeds in the same direction. Find the expression for the average speed of the vehicle. Please understand, we have been asked about the average speed. So suppose the distance the travel take is, this is d1, from here to here d2, like this. Okay. Now the speed it maintained at first d1 is v1, say d2 v2, like this it goes on and on. Now what will be the total distance? d1 plus d2 till dn. So d1 plus d2, d3 and dn. We don't know the distance, so we go up to dn. Total time here t1, here t2, till time tn. So let us add the time, total time, but we know the speed equal to distance by time, that is time equal to distance by speed. So in this case, this is d1 by v1. So time first t1 will be d1 by v1. Again t2 will be d2 by v2, like this it goes on. Average speed is what? Capital D by t. That is, capital D is simply the addition of all the distance, and time we just found out to be d1 by v1 plus d2 by v2 plus d3 by v3 till dn by vn. So if the vehicle starts or travels two equal distance, say d1, d2 equal to 2, means if we are here and here, this is d1 which is equal to d, this is d2 again equal to d, so both are equal to d, and see velocity v1 is maintained here, v2 is maintained here. So this is for d distance, this is for d distance. What will be the average speed? Total distance is d plus d, that is d plus d, 2d. And what is the average speed? This is t1 plus t2 in the denominator, and t can be easily obtained by d by v1 and d by v2. So we add them, d will cancel out. It will be 2v1 v2 by v1 plus v2. So average speed totally dependent on the velocity. A person walking in a straight line covers half of the distance to be traveled with a speed v0. For half of the time to complete the remaining distance, he walks with a speed v1, and for remaining half time, his speed is v2. What is the person's average speed during the complete walk? The question is like this. A person walking in a straight line, he covers half a distance, so d by 2 he covers in v0. And again we have distance of d by 2 here in the second half, but in the second half, for the half means again d by 4, right? It travels with v1, and here it travels with v2, again the distance d by 4. So you have to compute the average speed. So let us say total distance is d, so half distance is d by 2, and t1 we take as the time which is taken by first distance to cover, and we take this as 2t. Why? You'll just know. This we took as t1, this we took as t2. Now we know that the distance is average speed into time. In the first case, the speed is v0 and the distance is d by 2. So if we take t1 as the time, so simply distance traveled d by 2 will be equal to v0 into t1. So t1 can be obtained by d by 2 v0. This is the first expression for this half. Now let us go to this half. And the next one, the distance we have just computed lines, right? Now the next one, this d by 2, total d by 2 is covered in how much? We say that this is 2t. Why we take 2t? Let us take this as t, this as t. But for the computation, d by 2 will be v1 into t plus v2 into t. So this will be v1 plus v2 into t. So what we got, 2t will come here and v1 plus v2 will go down. So 2t is d by v1 plus v2. So the total time travel is, we took first half as t1, second as 2t. So t1 plus 2t. So the average speed will be what? Speed we know, distance by total time. But t1 we have just computed to d by 2 v0 here. And second time is d by v1 plus v2. We put here. And this distance is total d from here to here. All the distance is d. So just we rearrange them, d cancels out, and this is the final value. So position time graph for motion. Motion of an object, we will represent it by position time graph. Position is where that object is lying at certain time, and at some other time where this position is. And it's a very powerful tool in order to represent and analyze different aspects of motion of an object. When we talk about motion along a straight line, we say the x-axis, the x coordinate is varying with time. So we have a xt graph. This is for x coordinate, this is for time. The slope of delta x by delta t, the slope basically, we'll talk about this. This is the slope. This theta we are talking about, and this is delta x, this is delta t. So tan theta is simply delta x by delta t, and this tan theta or slope of graph will give us the average velocity of an object for a given time interval. This theta is the angle. This is the angle between time axis. This is the time axis, and this and the line, right? This is the line and the time axis. So this xt graph we have for different types of motion. For example, you see this is a time and this is a x, means distance. Now here some distance is there, x0. With time, this distance is not changing. That means the object is at rest. In this case, say it started from x0, it reached at t1 time to x1, and then at t2 time to x2. So if we take these 2 points, then this is the theta. This is theta we are talking about, and this will be, what will be the value? See, this is x2, this is x1. So x2 minus x1 is this one, and what is this? This is t2 and this is t1. So t2 minus t1 is this distance. So x2 minus x1 by t2 minus t1. This is what we are talking about. This is the theta, or you can say tan theta. Now this is accelerating, means the distance is increasing with time. Here the distance is decreasing with time. This is time, but the distance is decreasing. So it started with x0, then it came to x1 and x2. Now we want to find this theta. This will be what? This by this. This tan theta we know is perpendicular by base. This is perpendicular. What will be the value? x1 minus x2, because x1 is greater. x1 minus x2. So in this case it will be x1 minus x2 and divided by, what is the time? At x1 it was t1 and t2. So time will be same, t2 minus t1. So we see we'll get some value in negative. Why? Because this is deaccelerating. Here it is accelerating, means the distance is increasing with time. Here the distance is decreasing with time. And here this is a random motion. This is a curve. This is a curve. So here we don't have a proper uniform speed, but it is accelerating, accelerating. And we'll talk about how to find out the value, that is x by t, or you can say the velocity, with this kind of graph or xt graph also. So in the first case, xt graph, as we said, that the line is parallel to time axis, so object is at rest. So slope will be what? It will be 0, because the velocity is 0. Object is at rest. In the second case, as I described you, that the motion is very uniform, that is it has a constant velocity. So it was x2 minus x1 by t2 minus t1. This was the slope, and this slope is nothing but the velocity. This is the average velocity of an object. It is positive because it is increasing, moving in the x direction, and the slope is negative when the object has negative average value and it is moving in the negative x direction. The xt graph of any curve, instead of straight line, we call it as a non-uniform motion of an object. So motorcyclist, it travels in a straight path to a petrol pump in time 60 seconds. Now, which is at a distance of 120 meters in the east direction from his house. So see this one. This is north, south, east, west. So what is happening here is the motorcycle travels straight path to a petrol pump in time 60 seconds. Distance is 120. So distance is say 120, and for 60 seconds it has traveled. So it has traveled like this. The next is he stays there for filling up petrol for 120 seconds. So for 120 seconds it stays and comes back home by the same path in 90 seconds. So he comes back again to this 0 distance. So it comes back in another say 90 seconds. So after 90 seconds he gets ready for the office. His office is on a straight way at a distance of 300 meters in a west direction from his house. So he stays there for some time and then he starts again for his office, west direction. He takes now 120 seconds. So this will be around 120 seconds, yeah, from here to here, 120 seconds. Draw the graph of position time for the motorcycle and find the average velocity for different time intervals. So the graph will be something like this. Let us see it formally. So what is happening here is he starts from 0, he goes to 120 meters in 60 seconds. Then he stays at rest for another 180 minus 60, that will be 120 seconds. 120 seconds he is at rest. Now he comes back to again 0. This is 0 line. So he comes back again, and this is the time he has taken from here to here. It is 270 I guess, because it took 90 seconds to come. Then he stayed again for some time, and at this time he starts for his office at this opposite direction. So time taken, or you can say take the house as the origin. We can consider the displacement in east direction, which is positive y. This is positive y, and here we can take as negative y. So the position time graph you saw in the figure. So the average velocity of motorcycle in OA region, that means this region. What was that? Because delta x, it started from 0, so it reached to 120 meters. So 120 minus 0, then it started with 0 time, and the time it took was 60 seconds. So 60 minus 0, that is 6 to the 12, so 2 meters per second. Now for the second, because there was no movement, so the average velocity will be 0. In the third point, from here to here, see, we take the final with the initial. So 0 minus 120, because he again came back to the house. So 0 minus 120, but he took around this much second. So we know that this is already given as 90. You can directly take as 90, but still for the sake of completion we showed like this. This is minus 1.33 meter per second. So in the next part, that is this part. I'm talking about this part. So it was minus 300 minus 0 because we are taking in the negative direction, because we took this as a positive direction, this has negative direction. So minus 300 minus 0 by the time which is given, which is already given, so 480 minus 360, which is minus 2.5 meter per second. So plus and negative sign, what you see here, it indicates the average velocity of a motorcycle is in east direction and west direction respectively, plus for east and negative for west. The instantaneous velocity and instantaneous speed. So when you are moving like this, so you know the average speed, you know the average velocity. What about somebody asks you that what is the speed here? So we saw the average velocity in any time interval. So there was a time interval from here to here. So this is okay, but if you are being asked that how fast it move at different instant of time, at particular instant of time during that time interval. So for that, let us suppose a particle is moving in some direction, one direction. The position is x and it goes for delta x. At x it was at t, and when it moves at delta x it was with delta t. So we get the average velocity of this particle at time interval delta t for the equation. We'll see about that. And we do not have the information about the velocity at different instant. We want that it has to be, because if you take time here, it is infinite time. This time, this time, this time, this time, infinite time is there. So during this time, the interval, the velocity of a particle, it might have increased, it might have decreased, but how to know this? We want smaller and smaller time interval. We want not this type of interval, we want very small interval. And as we go closer to a very short time, we get more and more information about the velocity at that time. So let us see the illustrations to actually understand what is going on. A car starts from rest, say at t equal to 0. It moves to a straight line, say in plus x direction. The velocity of car increases with time. Now a person who is sitting in the car, he takes reading and through speedometer at every second, and he notes them along the distance being traveled. And speedometer, as we know, indicates the speed of car at that instant. But our car moves only in one direction, so the speed and magnitude of the velocity will be same. So reading of speedometer comes in kilometer per hour, but we assume that it is in meter per second. So what are the tabulations, observation he has given? He took the readings like this. At 0, it was all 0. At 1, say 1 second, the displacement from the origin was 1.5, and the reading on the speedometer was 3. So in the same way, at time 3, it was this displacement and this was the speedometer. Now suppose we start from here at t equal to 3. To calculate the velocity, we must know the displacement of the car, which is what? 13.5. And we must know the displacement of car, and for this displacement we need some time. So what will be the time, say from 3 to 6? The t1 is 3 and t2 is 6. So there is a difference of 3. So we say delta t is 3. We don't agree, we don't take this, but we say t plus delta t. So t1 plus delta 3, delta t is 3. So we reach at 6. So what will we do here is, delta t we start at 3 seconds. We said okay, the interval between, or the time interval is 3 seconds. We start with t equal to 3. We add this 3, that is t plus delta t. This is 3, this is 3, it becomes 6. In this time interval, the average velocity is displacement at 6 seconds, displacement at 3 seconds, divided by 6 minus 3. Of course, it will be 3 seconds. So what is the displacement at 6? See, displacement at 6 is 54. Displacement at 3 is 13.5. So when we take these values, 54 and 13.5, we subtract them, divide it by 3. We get some 13.5. But in the table, if you really go and see the value here, it is 9. At t equal to 3, it is 9. Reading of speedometer is 9. And what we are getting here is, we are getting 13.5. So it is way beyond the actual value which we have got. So in this calculation, for a time interval t equal to 3 seconds, the value of average velocity, it differs a lot from the true value. It has to be 9, but it came as 13.5. So we reduce now the time interval. It was 3, it was very large. So why not to make it the interval as 1? So in this interval, the value of the average velocity is 24.13.5. If you go back to the table, you'll see, and the time is only 1 second. So it is 10.5. Now again, it is not closer to 9. So the car is moving according to the position. We assume that the position is given by 1.5 t square. Just assume this. Now, if this is the case, if x equal to 13.5 and x equal to say 14.415, this, if you put t equal to 3 here, you get this. But if you put t equal to 3.1 here, you get this value. Now let us calculate with this formula, you can say, or you can say the equation. Now we have taken the time interval as 0.1 second, 3 second and 3.1. So this interval 3.1 minus 3 is 0.1. And what is the distance? 14.415 minus 13.5. So this is 9.15. So we have decreased the interval to 0.1 second, and we can again decrease the distance say to 0.05. Again we will use the same equation and we'll find out that the average velocity comes to be 9.07. Now this is much more closer to 9, which we wanted. So the idea is when we go on decreasing the time interval, when we made 3 second, 1 second, then when we move to 0.1, then 0.05. So we are decreasing, and the difference between the calculated value and the actual value is decreasing. Now the question will come, how much small time interval is sufficiently small? We cannot have a 0 value, but it should be infinitesimally small, which is near to 0, but it cannot be 0, because at 0 there will be no time interval. So why not to take limit? We know that limit delta t tends to 0 means it tends to 0, but it is not 0. It is very near to 0. So the circumstances in this scenario, 2 instant of time t and t plus delta t we will consider, and these are actually the same instant. That is t equal to 3 seconds and just near to 3 seconds. It is very closer to this, and we'll see that the value will come very closer to the observed value. So how to show it mathematically? Velocity will be delta x by delta t, that is x2 minus x1 by t2 minus t1. But here we are taking limit. So when we take limit delta t equal to tends to 0, then this delta x by delta t we know by mathematics that it becomes dx by dt. Dx by dt is the derivative, and you might have known when you learned the derivative, integrals, etc. Now dx by dt is called the derivative of x with respect to t, and what it gives you rate of change of position with time. Rate of change of position with time, and dx by dt is given by x dot above. What is instantaneous velocity from xt graph? Now here, say this one is the graph. Now you can take two positions p and q. You can join them and you can find the slope. But again, the distance t1, t2, the interval is large. So why not to take these 2 points? Again, you have distance is large. So by reaching here, at some point we'll reach as a tangent. This is a tangent. So we get a point which is just touching, but it is not 0. It is touching. So we want some delta t to tend to 0. So if we take this value, this line or this line, it will not worth. But if we take the tangent, then it will worth. So this tangent is simply delta x by delta t. Right? So this delta x by delta t, we just took some 3 seconds, now we took some 2 seconds, and now when we say delta t tends to 0, it is actually coinciding with the tangent, and this tangent is what we want. So now we have to note that for uniform motion, xt graph is a straight line, so that the value of instantaneous velocity is the same as the value of average velocity, right? And we are just talking about taking a tangent and finding the slope. So in instantaneous speed, here we'll just ignore instantaneous, we'll just call it as a speed. This is the magnitude of velocity. For instance, a velocity say plus 5.0 meter per second and velocity which is minus 5.0 meters per second, they both have a speed of 5.0 meter per second, because speed has no magnitude, no sign, only magnitude. So we have to take the magnitude of this. So speedometer of a car, it shows the instantaneous speed at that particular instant, and we have to note that though the average speed over infinite or say finite interval of time is greater or equal to magnitude of average velocity, the instantaneous speed at any instant is equal to the magnitude of instantaneous velocity at that instant, because we are taking the absolute values. Now the position of an object moving in one dimension is given by this equation. This is xt is equal to 4.2 t square plus 2.6. We have to calculate its average velocity in the time interval from 0 to 3, right? The instantaneous velocity at t equal to 3. So simply we know that x to the power n, differentiation of this is n x to the power n minus 1. We'll use this formula. Here xt is given by 4.2 t square plus 2.6. Now for t equal to 0 at this point, we'll put just 0 at this t, means here. So 4.2 into 0 square plus 2.6. The 2.6 is the initial position. When you take t equal to 3, that is here, t equal to 3, we get 4.2 into 3 square plus 2.6. This is the final position. And this is the final position, this is the initial position. We know that the average velocity is final position minus initial position, and the time interval is of course given as 3 minus 0. So it will be 12.6. How about finding the instantaneous velocity? We need to differentiate the position equation with respect to t. So dx by dt we have to do. So let us differentiate it. d by dt of this one, d by dt of this one. So d by dt of 4.2 t square is 4.2 will come out, t square is 2t. Here 2.6, because it is a constant, the differentiation will be 0. 4.2 into 2t, and we have to find t for t equal to 3. Put 2 equal to 3 and you get 25.2. Acceleration. You might have used a car or a bike or some vehicle like that. So when you increase the acceleration or accelerator, the speed will increase. When you decrease the accelerator or leave the accelerator, the speed will decrease. So increase and decrease. This is called acceleration. This is called deceleration or retardation. So if the velocity of a particle is the same for different time interval, it means that the particle moves with a constant velocity. But when the velocity changes, then the particle is in accelerated motion. So the time rate of change of velocity, the rate of change of velocity is called the acceleration. How to know about this? At t1 the velocity is given, that at t2 the velocity is v2 in a straight line. So the change in velocity is v2 minus v1. The change in time is t2 minus t1. The average acceleration is given by change in velocity by time. This is v2 minus v1 by t2 minus t1, which gives you delta v by delta t. So average acceleration is actually a vector quantity, because this is dependent on velocity. Velocity is a vector quantity. That is why average acceleration is also a vector quantity. So it has a direction. It has a direction which is the direction of the velocity. And SI unit of acceleration is meter per second square. And in order to find the average acceleration, we cannot know how the velocity of particle changes with time. So when we take limit delta t tends to 0, we got the instantaneous velocity. Here we'll get the instantaneous acceleration at time t. So instantaneous acceleration is called the acceleration, only acceleration. So this acceleration at time t will be simply a limit t tends to 0 for delta v by delta t, and this is given by dv by dt. And what is velocity? Dx by dt. A is dv by dt. That means we are differentiating this again. We have to differentiate v, which is dv by dt, put v here, dx by dt here. So we are doing d by dt of dx by dt. That is equal to d2x by dt square. So whenever we have an equation in terms of x, you just differentiate it twice. That is the acceleration. So this is the acceleration d2x by dt square. It is given by x with 2 dots above. Or what we can say that the second derivative of position with respect to time is the acceleration of a particle. If this dv by dt is positive, that is a positive acceleration along x-axis. Dv by dt is negative, that is acceleration is negative x-axis, on the negative x-axis. One more thing, if the velocity, that is velocity and acceleration, are both positive or both negative, then the speed is increasing. But if they have opposite sign, that is minus plus or plus minus, the speed of particle is decreasing. And when the speed decreases, we say that the particle is deaccelerating. And the direction of deceleration, or you can also say retardation, is actually opposite to the direction of velocity. For instance, the acceleration of a particle 2.5 meter per second square towards the east is same as the deceleration of 2.5 meter per second square toward west. So you can use this one. The position of a particle moving along a straight line is given by this equation. Now find the acceleration of the particle at t equal to 2. So what you have to do, you have to find dx by dt, then again d2x by dt square. Means you have to differentiate it twice. Let us take this one, differentiate it one time, you can do this one. I hope and I wish that you are aware of this differentiation. So we are simply differentiating it. Again we will take this and differentiate it again. You get 60. We have to find it at t equal to 2. Put t equal to 2, you get 6 into 2, that is 12 meter per second square. Now for a moving particle, the relationship between time and position is given like this, t equal to ax square plus bx. Please understand, the time is given in terms of x, not x is given in terms of time. So we have to do something here. Where a and b are constants, we have to find the acceleration of the particle as a function of velocity. So t is given like this. dt by dx is what? 2ax plus b. We are just differentiating it. But we know that the velocity is dx by dt, not dt by dx. So we have to invert it. We have to take the reciprocal. When we take the reciprocal of this, it becomes minus 1 to the power minus 1. So we have just overturned this one, dx by dt. Now, dv by dt can be written as what? dv by dx and dx by dt. And dv by dx and dx by dt. dx by dt is with us. But how to find dv by dx? d by dx of, because we have equation 1. This is dx by dt we can directly use. But how to find out this d by dx of this one? Because we have already this, we just try to find out d by dx of this one, right? Because this is already given. We are putting it and finding out the d by dx of this one. Because we know that what is this value. So again we will differentiate it. You get this value. This is minus 2av cube. So this is coming acceleration in terms of velocity. xt graph, vt graph. These are the graphs for accelerated motion. So xt, that means x and t, x on y-axis and t on x-axis. Similarly, when we talk about vt graph, that means velocity on y-axis and time on x-axis. dx by dt is v. We know that v is dx by dt. And the second derivative of this position x with respect to time is acceleration. That is dv by dt. That is double differentiation d by dx or d by dt of dx by dt. So d by dx of d by dx of dx by dt is double differentiation d2x by dt square. So the second derivative of any function is directly related to the curvature of the graph of that function. In xt graph, the point showed us what? Where the graph is more curved, the value of acceleration is more, and point at with this acceleration where this graph is less curved, then this d2x by dt square acceleration is small. So the point where this xt graph is concave up, that means this one, concave up, or you can say curved upward, the acceleration is positive and the velocity is increasing. Where in xt graph, if the graph is concave down, that is it is curved downward, the acceleration would be negative and the velocity will be increasing. So this is your xt graph. So at a point where this xt graph has no curvature, or you can say it's a straight line, the acceleration is 0. So this figure shows all the three scenarios we have discussed, the possibilities. That is, this is the first one, means let us start with the 0 one. Means here we have slope as 0 in xt graph. This is our whole graph. Here we have 0 slope, that is velocity is 0, and because it is curved downwards, so we say that okay, is this acceleration 0, velocity less than 0? Let me remind you again. When we have concave up, that is it is a positive slope, v is greater than 0 and acceleration is greater than 0. When we have a positive slope, again in this case, the positive slope means velocity is greater than 0. Always positive slope means velocity is greater than 0 and the curveness is 0 because it is a straight line. If you are getting a straight line, that is it is a is equal to 0 because it is coming at 0. See, this is at 0. This also is at 0. When we come here, we have 0 slope. There is no slope, so it is also curved downwards. That is acceleration is less than 0. In this case, we have a graph something like this. This is a tangent, so we have a negative slope. V is less than 0, acceleration is again 0 because their curveness is here. See, it is just like this. There is no curveness, so acceleration is equal to 0. When we come here, it has a negative slope because it is like this. So it has a negative slope, that is velocity is less than 0. And since it is, see, it is curving upwards, we say that acceleration is greater than 0. So in an xt graph, it's quite easy to decide what is the sign of acceleration. But what is the value of acceleration? xt graph can give you the sign, but what about the value? In this case, we need vt graph. Vt graph for moving particle. So from the vt graph, we can get average acceleration and instantaneous acceleration. The slope, that is v2 minus v1 by t2 minus t1, that is difference in the velocity at 2 time, difference in the time interval, delta v by delta t. This gives the average acceleration at any time interval delta t. So the instantaneous acceleration at any point is equal to the slope of tangent in what? In vt graph. If a particle is moving, the vt graph is parallel. If this is parallel to the time axis, the slope is 0. Like this. Here, the slope is 0. That is velocity time. Velocity is not changing with time. So there is no acceleration. The particle is moving with 0 acceleration. What it means is the velocity of the particle is constant. In this case, we say the motion is uniform motion. In the next scenario, in VT graph, as I just going to discuss with you, any other type of graph instead of this parallel line, the motion is known as non-uniform motion. Let us see a figure where you will see the slope of graph is positive. So what is the acceleration? If the slope is positive, in this case slope is positive, that means the acceleration is of the particle is positive. So here we see that the slope is positive, acceleration positive. What is this? This is v2 minus v1, this is t2 minus t1. So this is the slope, tan theta m. Here in this case, here the slope is negative, this is negative. So again it will be v2 minus v1 by t2 minus t1, that is the case, but still the m or tan theta is negative, that is acceleration is deceleration or it is retarding. So the graph, it can be a straight line like this. So slope of this line will be same for any time interval. In this we say, okay, the object is having a uniform accelerated motion. That is, we have a constant accelerated motion. For this motion, the average acceleration and the instantaneous means at some duration or at any single point, both the acceleration will be same. And this I was talking about, this is, I'll just come to this in a short while. Let us discuss about the next one. That is this one. The slope is negative. See, the slope is negative. Slope is nothing but this angle. It is negative. So we say that it is deaccelerating, and this is also a constant accelerated motion because it is a straight line. It is constant, but it is deaccelerating. In this case, if the velocity of the particle changes continuously with time, see, it is changing with time. So slope of the graph will be different for any different time interval you take. Here it is different, this time interval it is different. So the average acceleration will be also different at different time intervals. In this case, we call it as non-uniform accelerated motion. So the acceleration at any time is equal to the slope of tangent drawn at the curve at the point of time. So any tangent being drawn, this angle is the slope which is giving you acceleration. So the velocity time or Vt graph of moving particle can be used to find the displacement and distance traveled by the particle during a given time. So how to find this distance? The area under the curve of Vt graph will represent the displacement of a particle over a given time interval. So this is very important. The area under Vt curve gives you distance and displacement. So this statement is true for any type of motion. The area of Vt graph above x-axis will take as, like this is the motion. So we'll take this as positive, this as negative. The net displacement is actually the algebraic sum of this positive and negative value or area. So if you want to find the distance traveled, see, for displacement, positive, negative. But for distance, this will be positive, this will also be positive, this cannot be negative. So if you want to find the distance traveled by the particle, then the negative area of a graph should be considered positive. This has to be considered as positive. Let us take an example, you will understand it more. This is a Vt graph of a particle which is moving in a straight line, and we have to find the distance traveled during the first 2 seconds, means from here to here. and the displacement, total distance during the time 0 to 4 seconds from here to here. We have to find the displacement and distance. Acceleration from t equal to 0.5 to t equal to 2. So how to find this? First of all, as I said, we have to find out the area. So for the first case, from 0 till 2, this is a triangle, proper triangle. So half into base into altitude. What is the base? Base is 2. Altitude is what? It is 10. See, from here to here it is 10. This is 10. So half into base into altitude, half into AE into OB, which is the area of triangle OAB. And this is our triangle OAB. And this is half into 10 into 2. 2 cancels out, it gives you 10 meter. In order to find the displacement during 0 to 4 seconds, we will find out first the area of this section, that is OAB triangle, and this one means area of BCD. But this we have to take as positive, this we have to take as negative in computation of displacement. So delta x will be area of triangle OAB plus area of triangle BCD. OAB is half into base into altitude, that is half into A into OB. In this case we have half into base again BD into CF. Now this A is what? Plus 10 here. OB is again 2. In this case half CF is what? This is minus 10 and this is your BD, which is 2. So rather than taking this as minus, let us take this as minus 10. And when we compute, it is 0. So displacement is sum of the area, but the area which is below has to be taken as negative. That is why it is 0. But in order to find out the distance, we will take this area as positive and this area also as positive. That is, we just computed this to be 10, this to be 10. So 10 plus 10 is 20. Now we have to find the acceleration. So t is equal to 0.5 seconds, that is, we are talking about this point. What is the acceleration? Acceleration is slope of this line OA, which is simply 10 minus 0 by 1 minus 0, like this, 10 meter per second square. We come at 2. What is the slope of AC at this point, which is minus 10 minus of plus 10, means this line I am talking about. So this minus this by 3 minus 1, okay, means this area. So you get this as the acceleration. So this is A1, this is A2. Kinematic equation for uniformly accelerated motion. We have a particle which is moving in uniform acceleration, that is A is the acceleration along a straight line, which is say the x direction. Now at t equal to 0, the velocity is v0. At t equal to say some t, the velocity becomes v. So we have a velocity v here. The velocity time graph is like this. So we have say two areas. We can just say that if we are drawing v0 to v, we have one area is this, second area is this. You can combine this area in terms of trapezium also. But the derivation of kinematic equation for uniformly accelerated motion from the graph is very important, because three equations are going to come from this, and we are going to use this equation not here, but if you are preparing for some competitive exams, then these equations are very important. In this case, because we are talking about uniformly accelerated motion, the acceleration is constant. So the average acceleration and the instantaneous acceleration over certain period of time will be same. So acceleration, this A is what? Slope in Vt, we have slope of line AB. So this is V and this is V0. So V minus V0, and this time is t minus 0. So V minus V0 by t, what is this acceleration? Just take A here and rearrange. You get V equal to V0 plus AT. This is very important equation, first equation. So displacement of a particle during this time is equal to what? Displacement, as we said, it is just the area of region OABCD, that is OABCD, this area of VT graph. So what will be the area? As I said, we can divide it into two parts. One is this triangle, the other is a rectangle. So area of rectangle OACD and area of triangle this ACB. So what is this? This is from here to here it is V0, and from here to here it is T. So V0 into 2 is the area of rectangle. How about this area of triangle? We have this as T, this as v minus v0, so half into base into altitude, so half into v minus v0 into t. Let us say this is x, this is the displacement, and let us rearrange it. We get this as the equation, because we know that v minus v0 is equal to a. In the previous equation we just saw, this is actually equal to t, at. So let us rearrange, because we know v minus v0 equal to a, put it here, and just solving this we get x equal to v plus v0 by 2 into t. If we just rearrange, we get v plus v0 by 2, because we are taking this half as common, and this is the average. So v is, say, some average is always a plus b by 2. In this case a is v, b is v0, so this is average, so we can write it as a average. The average velocity is v plus v0 by 2. From equation first we get t equal to v minus v0 by a. Now let us put this in this 11.5. So when we put it here, x equal to v plus v0 by 2, we already had in terms of in the place of t we can put this. So we get another equation, x equal to v square minus v0 square by 2a. Take 2a on this side, we get 2ax is equal to v square minus vv0. So these three equations are very important. These are the equation for uniformly accelerated motion. These are the equation we obtained assuming t equal to 0. We said that it will start always from here, t equal to 0, but and also x equal to 0. There is no displacement at time t equal to 0. But this is not always the case. We have to get more general equation. So t equal to 0, say it starts from some x equal to x0, and it is not starting from 0, but certain value of x. So what we can do here is we have to replace all the equation with wherever x is there, we have to replace it with x minus x0 to make it more general. So these are the three equations when we put x equal to x minus x0. So in this equation, v0, v and a, they have to be considered according to which the motion of the particle is going on in positive or negative. So while you are putting this any value here, you have to see that you have to put the value with proper sign. A particle with initial velocity v0 moves with a constant acceleration in a straight line. You have to show that the distance traveled in nth second is v0 plus a by 2, 2n minus 1. So let us take an example. This is 9 second, this is 10 second. So in order to find the distance between these two, what we will do? The distance traveled at time 10 and distance traveled by time 9, we subtract this, that is, say d10 minus d9 you have to do. Say if this is n, so you have to do dn minus dn minus 1. Exactly, it is being done here. So distance traveled in nth second is distance traveled in n second, which is this case, minus distance traveled in n minus 1 second. So let us put in place of t, we put n. In the equation we know v0n plus half an square. In the same equation we will put n minus 1 in place of n. So v0 n minus 1 plus half a n minus 1 whole square. Let us rearrange it, something will get cancelled, and finally you get this as the equation. A train is moving with constant acceleration. When the ends of the train pass by signal, their speeds are u and v. Calculate the speed of the midpoint of the travel or train travel while passing the signal. So the case is, the scenario is like this. This is a train and this is the signal. It is starting from here. Then at some point it will reach like this. So the midpoint is just you can say coinciding with the signal, and the next is the train end reaches the signal. So this is the direction of movement. So the question is, what is the speed of the midpoint, this midpoint of the train, while it is passing the signal? So let us assume that the length of the train is L. The speed of the front, this means this front end of the engine, while it is passing through the signal, is say u. We just consider the train as a rigid body, so speed of all the say points will remain the same. And the speed of the back and bogie, last point, while passing the signal, say this is u. This means that the speed changes from this u, sorry, this is v. So u to v at a distance L. So this is L This is initial velocity, this is final velocity. And we know we have equation v square minus v0 square equal to 2x, or v square equal to u square plus 2s. Let us put the values here. Initial is this, final is this. So this is the equation. We are just putting these values. When it comes to midpoint here, so suppose the speed of the midpoint of this train is v dash. This means the speed changes from u. Initial velocity was u. It changes to v dash, but the distance is now L by 2. Again, we use the same equation. V dash square minus u square, this equation is equal to 2 into L by 2. And this gives you one more equation. Let us divide 1 by 2 and you get v square minus u square, v dash square minus u square. This AL gets cancelled, you get this equation. And let us rearrange it, you get v dash is equal to u square plus v square by 2 under root. Two particles start their motion from point A and B with velocity this much, these two. So A, B, one has velocity 252, the other has velocity 144. The acceleration is given as minus 4 meter per second square. In this case, it is 8 meter per second square in the direction A to B. So we have to prove that they will meet each other twice. So we will get some quadratic equation, we'll get some roots. Those two values are going to say that it is going to meet twice. So from where and when they will meet, we'll find this out. First of all, the time will be found, and then the distance will also be found. We have to consider the distance between A and B is 36. Okay. So let us convert this, because this is in meter per second square, this is in meter. Let us convert 252 into meter per second. So just multiply 252 by 5 by 18, you get 70. Again, we convert this 144 into 5 by 18, you get 40. So these are just the speed in meter per second. Acceleration A1 for first one is minus 4, the second one is 8. Now we'll just use the formula Vx equal to V0 t plus half a t square. For the first particle, we know the speed we have found out just to be 70, half into acceleration t square. This is the first equation. Now again, for the same equation, with the help of same equation, we are going to use the second one. But in this case, the distance is 36. So if somebody has traveled x, then other will be, if you say this total distance is x, right? So total distance is x, then other will be x minus 36. It might have reached here, so it has to be x minus 36. X minus 36, again, this is the velocity and this is the acceleration. We get another equation. Let us solve these two, or you can say just subtract these two. You get an equation t square minus 5t plus 6, which is a quadratic equation. I hope that you are able to solve this equation. You get two roots, t equal to 2, t equal to 3, and because the the count of time is 2, these particles meet each other at these two times. When you substitute this t equal to 2 in any of the equation, or t equal to 3 is any in the equation, you get x equal to 132 for the first timing. For t equal to 3 you get 192. So both particles will meet each other at 2 seconds, after 2 seconds at distance 132, at 3 seconds at distance 192. When brakes are applied to a moving particle, the distance it travels before stopping is called braking distance. We have to obtain the formula for the braking distance. So let us say that the distance traveled by the vehicle before it stops after the application of brake is ds. Because the object is here, or the motion is here, we are trying to stop it. When we want to stop it, say it travels a distance of ds, and we know that initial velocity is, say, some v0, but the final velocity will be 0 because it is going to stop. So we'll use this equation, v square minus v0 square is equal to 2ax. This is final velocity which is going to be 0 because it is going to stop, v0 square, and because acceleration is deceleration, that is, it is acting in the opposite direction, we have to take a as minus a, and when we rearrange this, we get ds equal to v0 square by 2a. So the when we brake it, or when we apply brake, braking distance is directly proportional to the square. It is directly proportional to the square of the velocity of the vehicle and the braking capacity. If you double the initial velocity, it will increase the braking distance 4 times for the same acceleration. And braking distance is an important factor when we are deciding that what will be the speed limit in school zones and hospital zones. Kinematic equations for freely falling body. Earth has its own gravitational pull, which is known as Earth gravitation force, and we know it as acceleration due to gravity. This acceleration due to gravity is always, if the object is like this, it acts downwards. This is actually at the center of the earth. So anything is pulled by the center of the earth. If you neglect the air resistance, the object can be said to be in free fall. And if the height through which the object fall is small, is very small compared to the earth radius, you can easily take g as 9.8 meter per second square. So this free fall is a case of motion with uniform acceleration, and this is the uniform acceleration. Now just consider the upward direction along y-axis like this, y-axis. So just put a equal to, because the direction is this, acceleration is on the other side, means opposite direction. So a has to be minus g, that is a equal to minus g. Let us put it in the equation. We know v equal to v0, and when we put a equal to minus g, it will be v equal to v0 minus gt. Again y equal to v0t minus half gt square. Then we have v square minus v0 square equal to minus 2gy. If we talk about free fall, the initial velocity will be 0, because if you are say you are on a tower, you are throwing something, and the initial velocity is 0, then of course it is going to get some velocity, some acceleration because of gravity. So it is always convenient to choose the vertically downward as the y-axis. So this as y-axis and upward as negative. So this as negative and this as positive. Then we get a equal to g. We don't have to put a equal to minus g then. And for a free fall, the yt, vt, at, that is distance time, velocity time and acceleration time graph are like this. First is the yt graph. This is the y direction, as I said. This is the time, and something is falling freely. So the distance is increasing but in the negative direction along with the time. In this case, there is this was the free fall yt graph. Now because the acceleration, we know that v by t or dv by dt is nothing but acceleration, and since it is common always 9.8, so we have a straight line like this. And how about the acceleration? Acceleration is always 9.8 meter per second square. So the AT graph will always show you a straight line which is parallel to your time axis. An object is thrown in vertically upward direction, that means in this direction. We have to calculate the time to reach maximum height, that is this height we have to find out, and the maximum height. We know that we have some initial velocity by which we will send, so we say it as v0, right? And at highest point, this v, it will be 0, because after this it will momentarily be on rest or 0 velocity, and then it comes back to us. So the upward direction we consider it as positive, then v0 will be positive, and if this is positive, then acceleration has to be negative. And we know that the maximum height will be reached at v equal to 0. So v equal to v0 plus at. Let us put all these values which we defined. 0 equal to v0 minus gt. T becomes v0 by g. So as we have got the time, the maximum height, let us take it as h. Now put y equal to h, t which we just found out to be v0 by g, and acceleration as minus g. Now let us put this in the motion equation. Y equal to v0 t plus half at square. We get h equal to v0 square by 2g. A stone, after having fallen from rest under the influence of gravity for 6 seconds, crashes through a horizontal glass plate, thereby losing 2/3 of its velocity. So only 1/3 velocity will remain. If it then reaches the ground in 2 seconds, find the height of the plate above the ground. So what is there? The velocity v of the stone, if it is striking the glass plate, so just velocity just before it is striking, if we take it as v, then this initial velocity, because the stone is at rest while it is being thrown, so initial velocity is 0 and final velocity we assume to be v, because acceleration is always at 9.8 meter per second square on this direction, time is 6 seconds. So let us put this value in this first equation of motion. We get velocity equal to minus 58.8. Now it is being said that it loses 2 by 3 velocity. That means it retains only 1 by 3rd velocity. So what is the initial velocity for the second case? That means after striking it, means after the strike is over, v0 is just 1 by 3rd of v, 1 by 3rd, say 1 by 3rd. This is 1, this is 1 by 3rd. So minus 58.8 is the velocity. What is 1 by 3rd of this? Minus 19.6. Now let us apply the equation again. The height of the glass plate above the ground, that means it is being thrown like this. So this is the glass plate. After this it reduces 2 by 3 and then is going to come back or wherever it goes. So h equal to v0t plus half gt square. v0 we just found out to be 1/3 of this velocity. The time is 2 seconds as given in the question. Gravity will always be on this side. But h equal to minus h. Why? Because the height is in the opposite direction. So minus h, if we take minus as this one, height has to be taken also in negative. So let us put this all in this equation. We get h equal to 58.8 meter. A coin is dropped from a balloon going up with a uniform velocity of 12 meter per second. So there is a balloon. It is going up in with a uniform velocity. Now this coin is being dropped from this balloon. If the balloon was 81 meter high when the coin was dropped, so when the coin was dropped, it was 81 meter high from the ground. Find the height when the coin hits the ground. So coin, when it hits the ground here, we have to find the time. We have to take g equal to 10 meter per second square. So at initial point t equal to 0, the coin is inside a balloon. So what will be the velocity of coin? Initial velocity is the same as what is the velocity of balloon. So after that it moved as a freely falling body. So we take upward direction as positive. Y is minus 81 because if this is positive, the y is going to be minus 81. Initial velocity is similar to the balloon, so 12 meter per second. And since velocity is going up, the negative direction will be for acceleration. So acceleration is g, that is minus 10 meter per second square. We apply the law of motion and we put all this value, we get a quadratic equation in terms of t. When we are going to solve for t using the Sridharacharya formula, we get t equal to 5.4 or t equal to minus 3. Now time with negative value is not, it is not possible. So we'll only take t equal to 5.4. Now during this time, at this time the balloon, because it was already 81, but because the coin has taken 5.4 seconds to reach, by this time 5.4 seconds the balloon might have gone up, because it is going with the uniform velocity which is 12, the time is 5.4, so how much it has reached up or gone up? 64.8. So 81 plus 64.8 is the height of the balloon when the coin actually reaches or touches the ground. Relative velocity. What is the concept? If you take a different frame of reference, the velocity will be different. And we always see that a person which is sitting in the train, the speed of fly in the train along the direction of moving train appears to be less. Means if the train is going like this and the fly is also going like this, the speed is going to appear less. But if the train is moving like this and the fly is coming like this, then the speed becomes more. The stationary person on the ground, on the train, first of all, it will find it higher. Why this is lower and why this is higher? How this concept can be discussed? First of all, this concept or the this increment or decrement in the velocity, this decrement and this increment in the velocity is because of the concept we know as relative velocity. So what is the relative velocity? Please take into account A. This is the frame of reference which is associated with the person which is standing on the ground. So a person is standing in the ground. A is the frame of reference which is associated with the person who is standing on the ground. Now B is the frame of reference which is associated with the train moving with a uniform velocity. So this is A frame of reference, this is B frame of reference. Now both these reference frames are inertial frame of reference. We are talking about a fly. So let us denote the fly with some point P. Okay. So what will be XPA? XPA is the be the position of P with respect to origin A of frame A. Again XPB be the position of P with respect to origin O dash of frame of reference B at time t equal to 0. Let us see this with a diagram. What I am trying to suggest here is this is first frame of reference which is ground. This is second frame of reference which is your train. Now this is the fly. So what is this? XPA. This is P with respect to first frame of reference, XPA. And what is this? XPB. This is the velocity or position of let us take position of P with respect to this frame of reference which is B. So this is XPA, this is XPB. Let us take this as XBA. XBA is the position or positional difference of these two frame of reference. Okay. Now in this figure, please see that XPA is simply equal to XBA plus XPB. So what we have done is XPA equal to XPB plus XBA. Now differentiate it with respect to t. So just differentiate it, and we know that dx by dt is velocity only. So VPA is equal to VPB plus VBA, and let us rearrange it. VBA will be what? VPA minus VPB. So VPA is what here? Velocity of P means fly with respect to reference frame ground. And what is VPB? The velocity of P with respect to the reference frame which is train. And what is VBA? The velocity of reference frame B with respect to the reference frame A. So in this example, let us take VBA as say plus 10 meter per second. This is the velocity of a train. So a train is having a velocity with respect to the B with respect to A, which is the velocity of train with respect to the ground. And if you take VPB equal to 2, which is the velocity of fly. So train is moving say somewhere 10, and the velocity which is the relative one. See, this is all relative. This is all relative. This is 2. The velocity of fly with respect to the train. So if we take this equation, this one, the velocity of the fly will be what? VPA will be simply, VPA is what? VPA is simply VPB plus VBA, that is, we have taken this as 2, this as 10 and this as 2. So 10 plus 2, which is 12 meter per second. And the velocity is actually greater than, it was 12, but it is greater than the velocity of the train. Velocity of the train is 10, but we added 10 plus 2. So the fly velocity is added to the train and it becomes 12. Now assume that this train is going like this and the fly is going like this. So if the fly in the train flies in the opposite direction to the motion of the train, now we have to take this as minus 2 meter per second. So again, applying the same formula, it will be not 10 plus 2 but 10 plus minus 2, that is 10 minus 2. So now the speed decreases. The speed decreases. So when they are in the opposite direction, the speed has to be subtracted. And now if P is the frame of reference which is associated say with ground, and references A and B, they are associated with some two particles. We'll see in the equation and diagram also. The relative velocity of the particle B with respect to A will be what? I'm giving you an idea about this, right? We are talking about this relative motion. So object is here A and B. Now they are moving, say A and B are moving together. So if A and B are moving together in the same direction, the things will be different. If they are moving in the opposite direction, the things will be different. So the relative velocity of particle B with respect to A, VBA, simply if we take it as ground, the velocity of ground means A with respect to ground, B with respect to ground. VBA will be VBG. We are just changing these A to G and B to G. So VBG minus VGA, that is VB minus VA. Okay. In the same way, the relative velocity of particle A with respect to B, VAB will be VAG minus VBG, which is actually equal to VA minus VB. See, this is VB minus VA. Here we have VA minus VB. So VAG and VBG are nothing but these two are AG and BG. These are nothing. These are nothing but the relative velocity. And what are the velocity of A with respect to ground, B with respect to ground? That is why, because they are relative to the ground, we are saying VA and VB simply. What is the relative displacement? We consider two particles, say A and B, which are moving along the x-axis, and with they have a uniform velocity, which is VA and VB. Now this is the distance XAO. XAO is the displacement from origin at time t equal to 0. This is also having a distance of XBO, means B means this particle, O is the origin. So distance is XB. What is the velocity VA? This is velocity VB. So what is the position when they are just starting, that is t equal to 0? Say some at t value, means they have started, and some t equal to t, it might have moved somewhere, and this also might have moved somewhere. So what is the position now? This is XA position, this is XB position, and what is the distance between these two? XB minus XA. So XA and XB are their position coordinate, and we can simply say that XA is nothing but, what is this XA? XA is simply XAO, means this distance, and the distance this A has travelled in time t. So VA into t, which is what? XA is the initial distance plus the distance it has travelled in time t, VA into t. Similarly, XB will also be equal to the initial distance from the origin plus the distance it has travelled, B has travelled in time t. And at time t, the displacement of particle B with respect to A will be what? We know that it will be XBA, so XB minus XA, sorry, XB minus A, like this. So XB minus XA, now subtract this from this, we get XBO minus XAO plus VB minus VAT. Here this is what? This is the displacement of a particle of B with respect to A, because at t equal to 0, initially we know that what was the difference. So VB minus VA, we know it as a VBA, that is the relative velocity of B with respect to A. Now when in this scenario, when VB minus, we'll take certain scenario, VB minus VA. Now when VA equal to VB, that means both have similar velocity, then this becomes 0 and we get only this equation. So XB minus XA is equal to XBO minus XAO, which means that the distance between two particles, if the velocity remains same, will remain equal to the initial distance at any instant of time, because they are moving with the same velocity. What happens? See, this is VA equal to VB, so this is moving with the same velocity, this is moving with the same velocity, so this distance will remain same everywhere. So the relative velocity of both the particle, because we started with this, and relative velocity will always be 0, VBA or VA equal to 0, because they are moving with the similar velocity. Now what happens when VA greater than VB, means A is moving faster than VB. Now if A is moving faster than B, then A is going to meet B somewhere at time t. This is what is happening. This is moving faster, this is moving slower. So at some point, because VA is greater than VB, they are going to meet somewhere. So at this instant, the relative displacement will be what? Because this is 0 at this point, at t equal to t. So thereafter the particle A will overtake it. At this, after t, it is going to overtake it. Now let us assume that VB is greater than VA. Now this velocity of B is greater than VA. Now, what happened? Because B has taken over, so VA, if it is going like this, VB is going like this, the distance will increase because this is faster. So both particles will increase with time, the distance between them. So they will never meet. When the driver of a Shatabdi Express running with the velocity V1 sights a goods train going ahead of him at a distance x in the same direction on the same track running with a velocity V2. Here it is being shown that V2 is less than V1. He applies brake. In order to avoid an accident, what should be the magnitude of the deceleration produced by the brakes? So the scenario here is, this is a track. When a driver of Shatabdi Express, say this one, running with velocity V1, sights a good train ahead of him at a distance say x on the same track. This is running with V2. But the velocity of V1 is greater than V2, so it is going to, if it doesn't stop, V1 doesn't stop, it is going to end with some mishap. So in order to avoid the accident, he has to apply, the Shatabdi driver has to apply certain brake. So what is the magnitude of this deceleration? Now this is the velocity of V1, this is the velocity of V2, and the velocity of Shatabdi Express relative to the good train is simply V1 minus V2, as we just suggested in the previous discussions. So if this relative velocity will become 0 in distance x, then only we can say the accident can be avoided. So what is the necessary deceleration? That is A. We'll use the equation of motion 2ax equal to v square minus v0 square, and this v0 square will be simply the relative velocity. This is 0, final velocity will be 0 because it is going to come, Shatabdi has to come at rest, and A has to be minus A because this is deceleration. When we rearrange this, we get A equal to v1 minus v2 whole square by 2x. Two cars A and B are at position 100 and 200 meter from the origin at t equal to 0. They start simultaneously with constant velocity this and this, respectively in the same direction. Calculate the time and position at which they will overtake one another. So what is given here is, first is A. So AO is 100. Then we have B, which is at 200. This is at 200. XBO is 200, XAOX is 100. Velocity of A is 10 meter per second. This is 10, and the velocity of B is 5. Now we know that this expression we have devised, XB minus XA is equal to XBO minus XAO plus VB minus VA. We know all these values. Let us put this with time t. Just assume that at t equal to t, they are going to overtake. When they are going to overtake, that means XB will be equal to XA. So XB minus XA will be 0. So let us put this value as 0. Other values remain the same. T will be equal to 20 seconds. Now let both car they overtake at some x from XAO. Okay. So x equal to XAO plus VAT. It starts with 100, means initial position of x is 100, and in this time t, VA will move what? What is the distance? Speed equal to distance by time. So distance will be speed into time. So speed of A is VA, t is we just found out to be 20. Let us add 100 with 10 into 20, that is 300 meters. The distance between Ahmedabad and Vadodara is 100 km. Two trains set off simultaneously from Ahmedabad and Vadodara towards each other. So Ahmedabad, Vadodara. One train starts like this, other train start like this. The speed of this train, one is 45, the other is 30. When will they cross each other? So speed of train which is set ahead of or say set off from Ahmedabad is VA 45 km per hour. Then the speed of train set off from Vadodara, means from here, if it is 45, we have to take this in the opposite direction as minus 30. XBO minus XAO, that is the train, they are in opposite direction. So what is the distance, which is 100 km? X of these two are 100 km. So when they are going to meet somewhere, the relative distance displacement, sorry, not distance, displacement, XB minus XA will be 0. So we'll use again this expression which we have found out from our discussion. xb minus xa is 0, xbo and xao we know the difference is 100, and we have used both these velocity with proper sign, and time will be 4/3 hours. What is frame of reference? This is a place or a situation from where an observer takes his observation, and this is called the frame of reference. What is the path length? The distance being traveled by a particle in some time interval, like this is the distance, and the change in the position of an object in some time interval is called displacement. So from here it starts, comes here, so this is the change in the position, this is called the displacement. If you add all these, it is the distance. So displacement is simply the final position, this is f, minus the initial position. The displacement can be positive, negative or 0, and the path length can be equal or greater than the displacement, but it cannot be less than. Average velocity and average speed, or the ratio of path length to the time taken for traveling it, is known as average speed. The ratio of displacement and time taken to travel is known as average velocity. The average velocity is given by delta x by delta t, which is displacement by time. Average speed is always positive, the direction is not important, it's a scalar quantity. Average velocity is in the direction of displacement, so it can be positive or it can be negative. And for a given time interval, the average speed can be equal, greater than the average velocity. Now, instantaneous velocity. If something is moving like this, we want to find out at this instance what is the velocity. For a given time interval, say from here to here, the average velocity does not give the information about how fast the object moves at different instance, like for example this instance. So by taking the limits, which is delta t tends to 0, very small time, the definition of average velocity becomes instantaneous velocity. So instantaneous velocity is delta x by delta t when this delta t limit tends to 0, and this becomes dx by dt. So the magnitude of instantaneous velocity is called the instantaneous speed. When a particle is moving in a straight line, it covers the same distance in the same time intervals, and its motion is called uniform motion. We have various graphs, xt graph, vt graph, at graph. So xt graph, the slope in the xt graph, the slope of a line which is connecting the final position, initial position, that is x2 minus x1 by the magnitude of time interval, so t2 minus t1. So this is the slope, and this gives you the velocity at that instance. Average acceleration and instantaneous acceleration, if the change in the velocity of object is delta v in delta t time, so average acceleration will become delta v by delta t. What is the instantaneous acceleration at some point t, which is simply delta v by delta t, where delta t has to tend to 0. So this becomes dv by dt, or you can say you are double differentiating the distance. So d by dt of dx by dt, that is d2x by dt square, this is the acceleration. Acceleration is a vector quantity, and it is in the direction of change in velocity, and this SI unit is used as meter per second square. The slope of velocity, when we talk about VT graph, this is V, this is T. So the slope in the VT graph gives you the average acceleration of a given time interval. So the slope of the tangent which is drawn at some point, say if the graph is like this, the tangent is being drawn here, it gives you the acceleration at that instant. So if velocity and acceleration, they are in same direction, the speed of the particle is increasing. If they are in opposite direction, means opposite side magnitude, you can say, the sign, the speed is decreasing. This is known as the deceleration of a particle. The area under which, like this, some area is there. So the area under VT graph for a given time interval is the displacement or total distance of the particle. For displacement, we will take positive, negative. If this is the graph, this is plus, we have to take this as plus, this is negative for displacement. For distance, we have to take this as plus and this as plus. So we have to add these two. So that is what the total distance. Consider the negative area also as positive. There are certain kinematic equations for uniformly accelerated motion. V equal to V0 plus AT. So V equal to U plus AT. S equal to UT plus half AT square, and V square is equal to U square plus 2AS. These are the values, and in the chapter wise or the discussion wise we use like this. The velocity of particle with respect to A is VBA, which is simply VB minus VA. The velocity of particle A with respect to B, which is VAB, is VA minus VB. And these two are opposite. So VBA is equal to minus VB. So this is about motion in a straight line. Thank you so much and take care of yourself.